10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
And we have a lift off. Let's know more about ISRO and its humble beginnings. ISRO, Indian Space Research Organization, was started on 15th August 1969.
It was started with a vision to harness, sustain and augment space technology for national development while pursuing space science research and planetary exploration.
ISRO's first mission was the Aryabhatta spacecraft, named after the famous Indian astronomer, was India's first satellite. It was completely designed and fabricated in India and launched by a Soviet Cosmos 3M rocket from Kapustin Yar on 19 April 1975. With the success of Aryabhatta, ISRO launched a series of geostationary satellites called INSAT satellites since 1983. INSAT satellites are used for telecommunications, broadcasting, meteorology, and disaster management.
GS8, geosynchronous satellite, are communications satellites. These satellites are mainly utilized for digital audio, data, and video transmission. Out of the many GS8 satellites launched by ISRO, 18 are still operational. GS8-1 carrying 3 C-band transponders and 1 S-band transponder was launched on 18 April 2001 by GSLV-D1.
Polar Satellite Launch Vehicle (PSLV) is the third-generation launch vehicle of ISRO. After its first successful launch in October 1994, PSLV emerged as a reliable and versatile workhorse launch vehicle of India.
The vehicle has launched numerous Indian and foreign customer satellites. Besides, the vehicle successfully launched a spacecraft Chandrayaan-1 in 2008 and Mars Orbiter spacecraft in 2013 that later traveled to Moon and Mars respectively. The long string of consecutive successes and multi-satellite launch capability has reinforced the status of PSLV as a reliable, versatile, and affordable launcher in the global market.
In its 39th flight, ISRO's PSLV successfully launched the 714 kg Cartosat 2 series satellite along with 103 co-passenger satellites today morning, 15th February 2017, from Satish Dhawan Space Center, Sriharikota. This is the 38th consecutively successful mission of PSLV. The total weight of all the 104 satellites carried on board PSLV C-37 was 1,378 kilograms.
Chandrayaan-1, India's first mission to Moon, was launched successfully on 22nd October 2008 from Sriharikota. The spacecraft was orbiting around the Moon at a height of 100 kilometers from the lunar surface for chemical, mineralogical, and photogeologic mapping of the Moon. The spacecraft carried 11 scientific instruments built in India, USA, UK, Germany, Sweden, and Bulgaria. The very first attempt, Chandrayaan-1, which was India's first deep space mission, resulted in the discovery of water molecules in the lunar surface. It confirmed prior scientific speculation and again catalyzed a global interest in moon missions.
Mars Orbiter Mission (MOM), India's first interplanetary mission to planet Mars, was launched on board PSLV C-25 on 5th November 2013. ISRO has become the fourth space agency to successfully send a spacecraft to Mars orbit. The primary goals of this project are technical in nature and involve the design, development, and launch of a Mars orbiter spacecraft capable of functioning autonomously throughout the travel phase, Mars orbit capture, and in-orbit phase around Mars. India's ability to successfully realize the complex mission to Mars in its first attempt, in a cost-effective, Rs 450 crores, has captured the world attention and has propelled India's image as a credible space-faring nation to greater heights. Mars Orbiter mission is a mission of national pride which has attracted the attention of students, general public, media, and international science technical community. The second mission to Mars, Mangalyaan 2, also called the Mars Orbiter Mission 2, will be an interplanetary mission by ISRO with a planned launch date in 2024.
Chandrayaan 2 mission is a highly complex mission, which represents a significant technological leap compared to the previous missions of ISRO, which brought together an orbiter, lander and rover with the goal of exploring South Pole of the Moon. The lander was named Vikram, after Vikram Sarabhai, the founder of India's space program. It would have landed near the Moon's South Pole, at a latitude of about 70 degrees south. The mission cost approximately 603 crore, $87 million. Chandrayaan 2 encountered a partial failure in September 2019 during its descent phase to the Moon's surface. The Vikram lander, which was meant to make a soft landing, lost communication with mission control at an altitude of about 2.1 kilometers above the lunar surface. Consequently, the lander crash-landed on the Moon, impacting at a higher velocity than intended.
Although Chandrayaan 2 partially failed, it paved a way for a successful mission to Moon Chandrayaan 3. Chandrayaan 3 has made history by becoming the first mission to soft land on the lunar South Pole, a region that has never been explored before. Chandrayaan 3 aimed to investigate permanently shadowed regions near the South Pole for potential water ice and resources. The Vikram lander's controlled descent achieved one of the closest approaches to the Moon's South Pole. The renowned scientist, who has been a faculty member at the University of Manchester, said the Chandrayaan 3 mission, within days of its soft landing, has already relayed data about the presence of sulfur near the south pole of the Moon. Vikram lander drilled into the lunar surface, revealing temperatures 8 centimeters beneath the surface. It found that these temperatures showed a difference of 60 degrees Celsius compared to surface temperatures. In 2026, the Indian Space Agency, ISRO, and Japanese space entity, JAXA, aim to launch the Chandrayaan 4.
Aditya L1 shall be the first space-based Indian mission to study the Sunday. The spacecraft shall be placed in a halo orbit around the Lagrange point 1, L1, of the Sun-Earth system, which is about 1.5 million km from the Earth. Satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any eclipses. This will provide a greater advantage of observing the solar activities and its effect on space weather in real time. The suits of Aditya L1 payloads are expected to provide most crucial information to understand the problem of coronal heating, coronal mass ejection, pre-flare and flare activities and their characteristics, dynamics of space weather, propagation of particle and fields, etc. ISRO has targeted 6th January 2024 as the day when Aditya L1 will be placed into the halo orbit around Earth at this point.
ISRO, your experiments are building our future and inspiring the world. Here's to your continued success in reaching for the stars.